Hello everyone, welcome back. In this video we're going to talk about assigning load to the frame, to the model that we have. Now in the assign section, part of load, we have joint load. If you have there is different ways to deal with the joint loads. You can give some displacement. Let's say that you want to analyze this building. What will happen if this joint here, let's say specific joint is going to settle. Let's say you have a settlement, then you're going to measure settlement analysis. So you can just simply choose some points and give them a settlement, displacement settlement we call it, and then analyze the building just for settlement, no load. Or we can basically assign the frame load, shell load that we have. In Etabs, there is different way. Why we have frame load and shell load here? We know loads basically start from the slab, it goes to the beams, to the column, and the foundation. So we apply shell load. So in the shell load we have uniform, non-uniform temperature, wind pressure coefficients. The one that we focus now for this course will be uniform. Live load, dead load, super, if you have it. Now remember in the beginning when we defined load pattern, we have dead. The dead, it's one inside it. So the weight of the slab will be calculated by Etabs. If you want to add extra dead load, when you're calculating dead load, you're not going to calculate the weight of the slab. So remember this one because one is included here. So if I want to assign load, what we have to do, first selection, then assigning, remember. Now, when it comes to slab, you cannot say, like, let me select everything and apply live load. Maybe you have different live load. Why? Because we said according to occupation, some part of the building will have different live load. Let's say here is a storage, so you apply different live load. Here it's, let's say, different live load. This is the roof basically here. I have a roof, I can apply to all of them similar. But maybe in the first story, I have different. So according to the building, we have it here. We know the rooms, which room will be used for what. We can define different live load to them. So basically here we have it. The top is the roof, which will apply the live load on the roof, this self weight, this dead load extra to the roof. For the live load in the first story, basically, we called second story, whatever you call it, according to the room you will apply. So first selection, then applying the live load. We'll make it easy for the video to be short. So I'm going to go to first floor. This is basically the roof. I can select all the slabs like this. Or I could go to select and assign the slab. Select all slabs. Well, selecting the slabs, we're going to assign shell load. We go for uniform. Here, let's discuss this one. First, applying the load. So we have dead, live. You're not going to apply wind automatically because we select them automatic. So they automatically will be applied. We go for whether dead or live. Let's say I'm going for live here. Live selection. Then uniform live. Let's say we know what it's 4 kilonewton per meter square. The direction is gravity. Now, the option here is very important. Those options are very important here to deal with them. Now, what are those? You can add, let's say it's the first time that you're going to add, it doesn't matter. The first time that you're going to add, the default is replace existing load. There was nothing there, yes? Live load is 0. So when you say replace existing load, there is no live load 0, we'll change the 0 to 4. If you make a mistake, so you realize that, oh, in the top there was not 4, it was 2. What will you do? You'll come back again. By default, it still replaces existing. Let's say this is 4. This is 4. Let's make it simple way. You will just keep 4. By default, this replaces the existing load. You apply, press OK. You will see there is number 4 appearing on the slab. That's basically indication of the live load. Now, if I select the slab again, let's say we made a mistake. Let me just show you something. If I go to 3D and if I go to display, load assigned to shell, the live load. So you see number 4 is, we have it here. The number 4 is the appearing. You should have seen. Oh, it's most probably maybe in the elevation we can see it nicer. See if you can see the load assigned to the shell. It should appear in here, but I don't know what's the problem in case here. However, the loads will be appeared nicely here, that you have a live load applied to the shell. We have it here. However, we'll go back to the 3D. We have it here, or in the plan. We'll see the numbers for now. I'll focus on the numbers. We have it here. So, okay, the number we have it is 4 here. The number is 4. I mean, it's 4 applied everywhere. If I go back to assign, so if I select the slab, we have it, and go back to assign shell load uniform. Look, if I change this one to 2, this is replacing existing load. So it was 4, it will be changed to 2. Now it became 2. This is one way of dealing. Let's say I want to add something. Let's say all of them 2, but this one I want to make it 4. I can click on this one. I can change this one to 4 in this manner, replacing it. Look, only change this one to 4. This is 4, the rest is 2. I can even add it to existing load. I can add to this one. For example, I can add 2, but if I add 2, it will not change it to 2, it will add 2 to this one. So if I select this one, and this is 2, and this is add to existing load, so it will be 2 plus 4, and it will make it 6. Delete existing load, it's good if you want to delete something. You'll select the slabs, and you'll delete existing load, apply, the live load will be deleted. So those are the 3 options that you have: replace, add, or delete existing. Add is useful when you calculated something, extra load comes 1.56 something, and you want to add it to the structure. You don't want to replace. Replace means that you have to know the load before, add the load, you have it, you'll get the total, then you'll put the total back here. But adding whatever you found newly, you can just simply add. Let's say in the beginning we have 2.6 applying to this one here. This is 2.6. Later I want to add 1 point, for example, this value. If I want to add this one to 2.6, if I'm going to use replace existing, so I have to add 2.6 to this one, calculate what will be the total. But if I click on add to existing load, so whatever the 2.6 will remain there, and this will be added to 2.6. It became 4.0 something there, which you could calculate it before, but it's easier. Why would you do calculation when you can use these options there? So remember, those are the 3 options that you have. Selection first, then you can do multi-selection while the same window is open. So you can do selections, apply things. Let's say I'm applying live load 4, apply 4, and then you can add more. You can even change this, for example, the view. I can go to the first story, select this one, and still this active. So the assigning windows, most of them work this way. The background still working, and you can just leave this one here. I can go, for example, selection of this. Let's see, this is this land stair part here. I can apply 5 to this one. Then I can choose something else and apply more. There, whatever I want, I can apply them. And then press OK to finish it. This is how you assign shell load to the slab that you have it. Selection, and you apply the load, you have it there. I believe that's enough for the case. We have it here for the shell. Well, let's continue with the frame as well. Now, assigning loads to beam. Now, why we have to assign extra load to beam? Remember, the same thing. This is live load we added. Yes, we could add extra dead load as well. Selecting it. If you go to assign shell load, Uniform, you could choose this one to be dead load, and you add dead load as well. So dead load, when you're adding it, you will only add extra dead load to the slab because the self weight is already will be calculated by the program. So you add superimpose dead load to the slab. Now, beside the load that will be transferred to the beams, there might be walls over the beam. As we know from the drawings, there will be walls. So how do we calculate those? First, we do it by hand. We calculate the weight of the wall per meter length, let's say kilonewton per meter length, and then we'll come and add it to the beams that we have it. Let's say we have this beam here, this specific beam, we have it here, this beam. I know the load for the wall, those are exteriors. I can select all the exterior beams and apply a load together. So I can select, let me go to plan, it will be easy to work with it. Let's say I'm at this, and the exterior beams that I have them, those are the exterior beams, I'm selecting them. Normally for the exteriors we have the same. So here I prefer to divide this one because if case like this happen, look, I'll deselect this one here because I cannot apply to whole. Maybe the wall is not different. For example, the wall here might be different than the outside. If they are different, in that case you have to divide these into two in order to apply the load. You know how to divide by editing the frame. Let's say they have the same wall over them. You calculate the wall, you know how to calculate load by yourself. Then you're going to apply load to those beams. This is beside the load coming from the slab. This is basically the wall over the beams. You have to add those to the beams for analysis, not just the slab, also the wall over the beams should be added here. So we're going to go to assign frame load. Again, we have distributed. You can go for point load if you want. If you have point load, you go for distributed here. And the distributed here, it's going to be different than the shell one. Why you have trapezoidal load even on the, there is a possibility to have trapezoidal load on the beam. So you could use this one, the trapezoidal load. You will divide into four. I'm not going to go into this one, just explaining it. Consider it something like this. And like this, you give how many values? You give those values, 0 here, 1 for this one, at this point, at this point, at this point. So the load basically is 0. This is the second point, the third point, the fourth point. He'll give these values, he'll create a distributed, trapezoidal distributed for you. Uniform distributed is written at the bottom. So I focus on uniform distributed. And here you'll choose the load. This is basically dead load, we have it for the wall. Remember, I'm not adding the self weight of the beam. I'm adding extra dead load over here. So say you add to existing load, or if you don't like this way, you can specify another load extra. But we haven't assigned anything, yes, any dead load. So I can just simply say dead load, and its force, there is a kind of, you can add moment, I made it more. Going for force here, kilonewton, let's say it's 20 kilonewton per meter, the weight of the wall. I will just add it to those, over those beams that I have it there. So I'll apply, press OK. Now I have the load over the beams. Let's see if I can show you the, yes, it's shown here because I specified it before. So those are extra dead load coming from the wall. So I go for the interiors, maybe they are different. If this side over here, I didn't select this one because it was too, maybe the inside is different than the outside. How do I know this one? From the plan here, we'll see the wall. The wall outside, let's say there are 20. For example, if there is no wall over it, remember you're not going to provide anything. If there is no wall, no need to provide it. So I'll check the walls. Where do we have the wall? Remember, over it, not under it. So for example, those are the walls over the beams, those are on the ground. So I check those walls. For example, look at up to here. So this part here, till the column we had it. And there's another thing here. There's a balcony here. So I could have add over here as well, exterior. It's possible. And the same thing for this case here. Wherever we have the wall, those are 20 around the perimeter. And for the inside, if you have anywhere 20, you can add the 10s may be different. You'll add different load for those beams. Remember, you'll find the location of the walls and you add those over the beams that you have it there. This is why we have also assigning frame load distributed. I believe this will be enough for here. Joint load is we said that there's force and some ground displacement if you're willing to deal with them. Now after assigning the load, one thing will be remain that we can go for analysis and design. I believe this will be enough for the frame and for the shell loads that we have. Remember, for the staircase you could do the same thing. You can select the staircase and apply live load to the staircase. Similar, it's possible. It's not going to be any problem there. You can apply load to the staircase as well. Consider it as a shell loading thing.